I know. So what's equal? Not the outcomes. I'm glad you said that, because it's not necessarily the outcome of pizza and beer is fair, 50-50. Adam, you get 3 and I get 4. That's not necessarily the most efficient outcome, or that's not how we're going to gauge efficiency. So we still got a little football region. What's going on? What's equal? You're right. Something's equal to each other. I just want you to articulate that a little bit better. What is the slope of this? Right here at point X for Adam. How do we figure out the slope of a curve? What is it? How do we do it in general? The slope of a curve. Rise over run of what? Not the curve. But at point X, well, first of all, is this slope different at point Y? Yeah. So how do we find the slope of a curve at a point? What's tangent? It's the slope of what? It's not. It's the slope of something, but it's not. It's not like the change. If I take this number, let me X, Y, Z. If I take point Z, I can't take these 2 points and actually calculate the slope. We had a special trick that we did with the slope of a curve. It's the slope of the tangent line to the curve, which isn't necessarily the budget line. Our equilibrium condition had a budget line that was straight, and we knew that in equilibrium, the slope of the budget line would equal the slope of the indifference curve. But in general, it's the slope of the tangent line touching the curve, which that's what the tangent line is touching the curve. All right, so what is the slope of the indifference curve? What did we call that back in chapter whatever? What's it equal to mathematically? Oh, you guys thought you're done with that material. We'd never get back to it again. Good, close. Marginal rate of something. Marginal rate of substitution. So the slope of the indifference curve at point X is the marginal rate of substitution, which was equal to what mathematically? What was the rest of that? Marginal rate of substitution of beer for pizza was equal to, good, marginal utility of, which one went on top? Beer divided by the marginal utility of pizza. This was Adam's preferences of his willingness to trade one good for the other. All right, so what are the 2 things that are going to be equal down here at the efficient point? When their marginal rates of substitution are equal. Blake's marginal rate of substitution and Adam's marginal rate of substitution, when the 2 marginal rates of substitution are equal to each other, there won't be any football region. And so with this graph the way I've got it here, one notion of Pareto efficiency is that we're able to make at least one person better off without making anyone else worse off. So in other words, if I keep Adam right where he's at this level of utility, it's possible for me to make Blake better off without making Adam any worse off. And so that happens at this point, let's call it C, where the 2 are tangent to each other. And now we say that that allocation of beer and pizza is Pareto efficient. In other words, it's not possible to make anyone else better off without making somebody else worse off. Pareto efficiency. All right, so a couple notes we can track on here. Let me start with in general. If there is a quote-unquote football area, then there is a possibility to make one person better off, and I should say to make at least one person better off. We can make, as we learned, we can make them both better off. We can make them both better off is what we started with, right? It's possible for both indifference curves to shift, but it's possible to make at least one person better off without making anyone else worse off. Which means if there's a football region, it is not Pareto efficient. Pareto efficiency is that definition saying we can't make anyone else better off without making somebody else worse off. All right, and so we call this a special word. It's called exchange efficiency. We're going to talk about three different types of efficiency in this chapter. Exchange efficiency happens when the marginal rates of substitution between two goods of two people, so atoms, I'm just going to go ahead and write atom here. The marginal rate of substitution of Adam is equal to the marginal rate of substitution of Blake.
So what's the not Pareto efficient again?
This whole statement up here. If there's a football region,
So if you can make one person better without making another one worse, then it's not Pareto efficient.
right? Yep. If you want, I'll do a quick little shorthand because that's an important concept. So Pareto, so allocation, a distribution is Pareto efficient if no one can be made better off without making somebody else worse off. Without making somebody else worse off. And so that is called exchange efficiency. This is kind of the more technical aspect. And this is the slope of Adam's indifference curve. And this is the slope of Blake's indifference curve. Those two things are going to be equal in Pareto efficiency. Now, if I was going to use a mom and dad, if you guys were brothers, might be easier. But if we were to give, let's go up to this point here and just give, if we gave Adam most of the beer and all of the pizza, so Adam's in control of the refrigerator, right? Would we still be efficient? So if Blake's indifference curve and I'm just making up a point here now, there's a football region. Is there still room for making that efficient? Yeah, because there's a football region, right? So there's our football region. Is this allocation fair? So I can make Blake a little bit better off without making Adam any worse off. Adam still owns most of the fridge. Is this allocation fair? Adam having most of the goods. Not really, right? To our perception, but it really comes down to, well, what do you mean by fair? Did Adam work while Blake played video games all day long, and that's his money, and he bought the beer, and he earned it, and it's his pizza? Well, then maybe that's fair. And actually, Adam's being pretty generous by giving Blake a little bit of pizza, a little bit of a gift, right? So that's where the whole issue of efficiency versus equity, which is kind of the focus of this chapter. This allocation in some people's eyes might not be fair because Adam is the rich guy. He's got all the beer and all the pizza, and poor Blake over here has just almost nothing. Well, that's not fair, but it's efficient. There's no other allocation of beer and pizza that we can do that will make Blake better off without making Adam worse off. So if the benevolent dictator comes in and says, Adam, you have to share, and we're going to take away part here, and we're going to just give them to Blake, and so we're going to reallocate the goods of society to here, from here to here. Blake, as long as Blake and Adam are still able to trade with each other, they'll eventually come back to some equilibrium condition in the middle. And where I'm going with this is that all along here is points of efficiency. There's a whole bunch of these little guys all along here. Points of tangency. There's multiple efficient points, but what we call fair is up as a judgment call. Okay? This is important in terms of economics, that it is possible for us to redistribute wealth and still have an efficient solution. We can change the allocation without having to know everybody's utility function. The benevolent dictator can just tax Adam's pizza, give it to Blake, and put you here. Well, that's not efficient, but as long as we allow them to trade, it'll get to a point of efficiency. All right, that's enough for today. Any questions on that? I guess we got not much of a minute left, but isn't this fun? Good.